All right. So we were talking Thursday about linear programming, where basically it's a system that allows us to find an optimal solution in regards to like manufacturing, or in this example here, it's going to be in regards to like an airline wants to know how many tickets to sell, okay, of two different criteria. I think there's an adult ticket and or a first class ticket and coach ticket, okay? But it allows, linear program is a tool that is going to allow people in manufacturing to make decisions, people in marketing to make decisions, okay? So this is maybe a question targeting marketing, okay? Just trying to figure out how many seats to sell, okay? It says, so if we remember about linear programming, we need what we call an objective function. So the objective function is, remember, referring to maximizing or minimizing something, okay? And then we'll have constraints. And constraints, if you remember, those are the things that we are limited by, okay? So as we read this scenario, it says an airline offers coach and first class tickets, okay? It says for the airline to be profitable, it must sell a minimum of 25 first class tickets and a minimum of 40 coach tickets. So the company makes a profit of $225 for each coach ticket and $200 for each first class ticket. So at most, the plane has a capacity of 150 travelers. How many of each ticket should be sold in order to maximize profits? Okay. So what I'm going to do right now, I'm going to let's identify our variables first. Okay. And I think, and we talked about this on Thursday, but we're going to use Desmos to help us out here. And remember, Desmos makes us use X and Y. So I'm going to let X equal, okay, but now I'm going to redefine it, and I'm going to just say C for coach, okay? So I'm going to write all of our rules in regards to C, and when we get them all written down, then we're going to go back and replace those C's with X. Does that make sense? I think that's easier to do than to try to remember, okay, this is talking about first class. First class had what criteria in the problem, and then remember, okay, well, first class, we let that be what variable, X or Y. If I let it be C for coach, and I let F be for first class, there's no confusion there, I don't think, okay? So C will be, obviously, coach tickets, and we'll let Y, which is going to be also F, to be first class tickets. Okay. So, it says at most the plane has capacity of 150 travelers. How many of each ticket should be sold in to maximize profits? So I'm trying to maximize profits. Okay, maximize profits. You remember the other day we talked about profits or revenue, because profit I think maybe is a word that is kind of maybe used here as a misnomer, because we're really talking about money being brought in. We're not, my profits can only be realized, and maybe they've done this already, but profits can usually only be realized after I remove all my costs, right? Okay. Maybe they know that what their costs are per this airline. Okay. They know the costs for pilot wages, for maintenance, and all that kind of stuff, and have worked that out and figured out, even with all those costs, we're still making $225 for a coach ticket, $200 for a first class. But the amount that I'm making off of every coach ticket is $225. So if I sell one coach ticket, I make $225, right? If I sell two coach tickets, I make $250, correct? Or sorry, $450. Okay, so I double that. So my objective function is going to incorporate $225 for every coach ticket that I sell. So 225C, and that would give me, if I just sold coach tickets, my total amount, right? We talked the other day that to find a total like this, it's the price times the quantity. Well, 225 is essentially the price, and C is the quantity, and it's going to be 1 ticket, 2 tickets, 3 tickets, 4 tickets, however many I sell. And I'm going to add to that then my first class tickets and the money that I make off those. So the price of a first class ticket is 200 times then F. And that's my objective function. And your objective function should always be kind of that simple, that structure. Okay. Now we got to determine our constraints. Okay. There are 2 constraints that are always going to exist. Okay. One is that I have to sell a positive number, let me rephrase that, a non-negative number of coach tickets and a non-negative number of first class tickets. Basically saying you can't sell -2 coach tickets. Okay. Basically saying I cannot pay somebody to ride on my airplane, because that's what a negative price or negative coach ticket would be, right? So those have to be both positive. And those, at times, people forget them, and it doesn't alter the problem. Okay, those are just essentially telling us when we graph things, we're going to be in the first quadrant. Okay. Now there's some other things that are in here that are limiting me on capacity and the number of tickets I have to sell. Okay, it says it must sell a minimum of 25 first class tickets. A minimum of 25 first class tickets. So F, if I say minimum, okay, that means F actually has to be greater than or equal to 25, doesn't it? Does that make sense? Okay, minimum set in the floor. So you can have something, you can have 25, or you can have 26 or 27, but you cannot have 24. Okay, and maybe what they're saying here is that if we don't sell 25 first class tickets and 40 coach tickets, you ever fly on an airplane, like a commercial airline? Anybody do that? Okay, so first class is in the front of the plane, coach is in the back of the plane, right? And it's all about like weight distribution. Maybe that's a reason why they have to sell so many of these first class tickets, okay, and so many coach tickets. And maybe they say if we can't sell these, it's not profitable for us to even send this flight, so we're not gonna fly. Okay, but they might have their reasons on why that has to be greater than or equal to 25. I need a minimum of 40 coach tickets, so C has to be greater than or equal to 40. Okay, there's one more constraint. So these were my non-negative constraints. These are the number of individual class tickets that I have to sell. And there's one more constraint up here that we haven't talked about. And it's that right there. Okay. How could I express that as an inequality? It says at most. So when I say at most, can I have more than that? So it's going to have to be a less than or equal to, right? Less than or equal to what? 150. That's my capacity. Okay. So now what do I put over here? What are my algebraic terms over here? Remember, C stood for a coach ticket, right? F stood for a first class ticket. And those are individually talking about, you know, if somebody buys a first class ticket, that is one person out of this 150, right? Okay. So what do I do with C and F over here to determine how many people are going to be on my airplane? Does that make sense if I add the coach tickets plus the first class tickets? That will tell me how many people are on my plane. Now we need to maintain a number that is less than or equal to 150. Okay. So remember what we're going to do here. We're going to create a table, okay, of X's and Y's. So remember, X was our coach tickets and Y was our first class tickets. But we're going to create a table here of X's and Y's, and then we're going to plug those values into our objective function of 225 C plus 200 F, or if you want to use X and Y instead. But that's what we're going to figure out what X and Y values or C and F values that we need to plug in there that is going to give us the most profit. Okay? And the way we determine those points is by graphing these things. Okay? So some of you came to me last week and said, I'm filling in all this table stuff, and the table stuff is intended to basically organize your constraints and your objective function. Okay? And you're saying, I can't get this ordered pair. I don't know how to get this ordered pair. I don't know how to get this maximum number. All of the work that we're going to do here in a moment is getting that part. Okay? So we're going to grab Desmos. And we're going to type in all of those constraints. Okay? So remember, and if you want to do this, I think maybe it makes sense to do this now. Zoom in. So remember, X was C. So then wherever I see a C, I'm going to replace it with X. F was a Y. Y, X, X, and that becomes a Y. Okay? Because that's how I have to use Desmos. So I'm going to type in X is greater than or equal to 0. I'm going to say Y has to be greater than or equal to 0. Okay. And we can see where they overlap, right? Where are they overlapping? They're overlapping in the first quadrant, yes? Okay. Then we're going to type in that Y had to be greater than or equal to 25. And that X had to be greater than or equal to 40. Okay. So now, looking back, so right now we've got four different things being plotted here. We've got the red graph being plotted, we got the green being plotted, we got blue being plotted, and we got black being plotted. And we're looking for where they all intersect. Would you agree that they all intersect over here in this like dark purple region? Does that make sense to everybody? Okay. So far with the constraints that we have listed, we're looking at that as my feasible region. Okay. Now, we still have to put the capacity constraint in, which said X plus Y had to be less than or equal to 150. So we put that in. Okay. Now I know it gets messy, and what you can do to clarify some of the messiness using Desmos is that you can remove these two. You can remove your non-negative constraints, unhighlight them, because that just makes sure that we work in the first quadrant, right? Okay. So all you got to know is we're looking in the first quadrant, and we're going to look for the places where all of these things intersect. And one way you can, again, try to figure that out is you can toggle these on and off. So, okay, so there's one region, there's another, so we see where they're intersecting, okay? And we put the third one in, we see where all three are intersecting at this triangle, correct? So be okay with that? So what we learned on Thursday was that once you find this triangle is referred to as your feasible region. That means that your solutions are going to be at the corners of that triangle. Okay, so you have to click on those corners to get Desmos to actually show those ordered pairs. So one ordered pair is 40, 25. So 40, 25. Another ordered pair is 125, 25. 125, 25. And another one is up here, 40, 110. 40, 110. And what that does, guys, is it meets all of those conditions. Okay, if I add those up, if I add 40 and 25, add that first row up, 40 and 25. Were they less than 150 when I add them together? Yeah. Was the 40, was that greater than or equal to 40? Yeah, so it met that. Was the 25, was that greater than or equal to 25? and met that, right? Were they both 40 and 25 bigger than 0? So these are automatically going to be met. Okay. This next one, 125 and 25. Well, if I go 125 coach tickets, is 125 greater or equal to 40? Yeah. Is 25 greater or equal to 25? Yeah. When I add them together, do I get something less than or equal to 150? Yeah. Okay. And the same thing for 40 and 110. And those are the only 3 points out of all the points in the coordinate plane. Those are only 3 that are going to satisfy these and at the same time maximize that. Okay. Everything, just kind of looking at the picture here, everything in, see if I can highlight that feasible region for us real quick. Okay, every point in that yellow region will satisfy all 5 of those conditions right there. Okay, but only that one, and that one will either make my my objective function as large as possible or as small as possible. Okay, so now we just got to figure out which one it is. Which one is going to produce the largest or small. So what I think is important for us to be able to do here is evaluate these. Let's see here. So all we're going to do then is take this 225 225C plus 200F, and we're going to plug these numbers into those spots. So it'd be 225 times 40 plus 200 times 25. And then we'll do 225 times 125 plus 200 times 25. That kind of makes sense? Okay. Now, remember, we're looking for the one that is maximal, the one that is the most. Now, just a real quick question here. Is that amount right there the same as that amount right there when I evaluate these two? Which one of these is bigger, the yellow one or the green one? If I multiply those out without even doing any multiplication, which one's going to be bigger? The yellow amount or the green amount? The green one, right? So if the blue ones are the same and this green one is bigger than the yellow one, does that automatically tell me that this row, this ordered pair, is going to be more money than what this top one is? Okay, so if you are worried about consuming time and calculating these, that can maybe save you a little bit of time. You don't need to calculate this top one. We don't need that one because we know it's going to be less than what this one is. Okay, now because these here are varying, we can't do a comparison with these to determine which one of these is going to be bigger. But when we evaluate, and then I'm going to evaluate all of them just to confirm or convince you of that little strategy. But when I go to, and this is what I like about using Desmos, and hopefully you guys are getting used to it, I can actually type in the 225, either C or in this case X, it doesn't matter, and then 200F, and I can just say I want C to be 40, and I want F to be 25. And it will automatically plug, it'll do this calculation right there. That was when C was 40 and F was 25, and it gives me $14,000. So this is $14,000 that is made when I sell that combination of tickets. Okay. The next one says C is 125 and F is 25. There you see that it allows a profit of $33,125. obviously, and this is confirming that we knew this middle one was going to be bigger, right? And it's substantially bigger. It's more than double, okay? And then the last one will be when C is 40 and F is 110. We get $3,100 or $31,000. $31,000. So automatically then it tells me that I need to sell 125 coach tickets and 25 first class tickets to maximize my profit. Okay. Now, in all practicality, if I'm actually an airline doing this, I'm going to try to employ this. But if I sell 124 and 26, I'm going to be okay with that. Does that make sense? Okay. So they get this data, but it's not necessarily maybe data that they have to live and die by. Okay. But they're going to try to get as close to those points as possible. Does that make sense? And basically what I mean by that is, let's go back to our feasible region. The ordered pair, so this one was, so what was it, 125 and 25? And there was one that was, what, 25 and 110? No. 40 and 110. All right, so those were my 2 points that we were kind of debating on which one was going to be the maximum value. And one of them you saw gave me like 31,000. The other one gave us 33,000. But this is the one down here that gave us, that point right there is the one that gave us like 33,125. So what that means then is that these points in this feasible region that are close to it, they're going to give us a greater total than the points there that are close to it. Does that make sense? So they're going to try their hardest as an airline to get points that match up to that one as close as possible than the other one. All right, so let's do one more. Okay, so those of you that may be the driving force of a restaurant in the local vicinity, like I would argue that maybe at the local level they're not doing this, but you can. So a lot of times what they'll do is they know, like Texas Roadhouse, in their headquarters, they have analytics people. They know what the average party will spend, right? Okay. They know the cost of, like, or the profits that they make off of an average party of 2 people, an average party of 3 people, 4 people, and then obviously they know like the average stay time of those parties, and they can use that knowledge to set up a system here and say, this is how many people we need to get through, okay, to maximize a profit. And if they say, okay, we need to get this X amount of 2-party groups through, and 3-party groups and 4-party groups through, like an 8-hour block, that might be able to tell them then how they need to staff the kitchen, staff servers, staff hostesses, and that kind of stuff. Does that make sense? Okay. So here's kind of and that's a very intricate process at that level. So this is kind of like, I don't want to say dumbed down, but this is a simpler approach that a doctor's office might use. Okay. So the doctor, should just say doctor, but a doctor allots 15 minutes for routine office visits, and 45 minutes for full physicals. So the doctor cannot do more than 10 physicals per day. The doctor has 9 available hours for appointments each day. A routine office visit costs $60, and a full physical costs $100. How many routine office visits and full physicals should the doctor schedule to maximize her revenue for the day? Okay, so let's do, I think what the easiest thing is to find the optimal function, or the objective function. Okay, so our objective function is going to be found right here. You guys write real quick on your own what you're going to do with those 2 things to create an objective function of maximizing revenue. And I'm going to let X be the same thing as R, which would be a routine office visit. And I'll let Y equal P, which is the physical. Okay, so if I'm going to look at my objective function, okay, I will make $60 for every routine visit, right? And we'll make $100 for every physical. Do you guys come up with 60R plus 100P? Okay, some heads bobbing. Now let's do constraints. Okay, so we have a constraint about time, right? Okay, so the doctor gives 15 minutes for routine physicals, 45 minutes for full physicals, cannot do more than 10 physicals per day. The doctor has 9 available hours for appointments. Okay, so here's the issue with this. I'm right here. Everything there in yellow is referring to time, right? Okay. What is the problem there, though, in regards to time? Some of the units are minutes, and one of the units is hours, right? We can't leave them different, okay? So you're either going to have to change minutes into hours or hours into minutes. And I think the easiest thing here to do to talk about the time constraint is just to say 15 minutes for a routine plus 45 for a physical. That amount has to be less than 9 hours, which 9 hours in minutes, how many hours or how many minutes would that be? What's 9 times 60? What's 9 times 6? 540. So 540 minutes are available to. Okay? So that's I'm just going to put in parentheses here, that's my time constraint. Okay? It says I cannot do more than 10 physicals per day. So would you guys agree that physicals has to be less than or equal to 10? Okay. Does it give me any requirements on how many routine physicals I can give? So we've done the stuff in yellow. We've done that. It doesn't give me any other thing, right? So then we just got to remember that routine has to be bigger than 0, and physicals have to be bigger than 0. Okay. So again, if I want to go back with using X's and Y's, R is X, everywhere I see an R, I'm going to replace it with X, and P is the Y. So now I'm going to go to Desmos and graph these things. Okay, so 15X plus 45Y is less than or equal to 540. That was the first one. Okay. Y is less than or equal to 10. X had to be greater or equal to 0. And Y has to be greater than or equal to 0. So I like to just plot them all or write them out all first, and then I'll go back and kind of toggle them to see where they intersect. Okay. So obviously, the non-negative ones are telling me we're going to intersect in the first quadrant, right? So again, I don't like graphing those right off the bat. I think especially with Desmos, and you can't adjust the transparency of the colors it gets kind of murky sometimes. But if I put the other one in, so now we can see the intersection of all three are kind of this rectangle here, right? And then we'll put in this line, and now we see that the intersection of all three is going to be or not all three, but all four. The intersection of all four is that polygon there, okay? Meaning to us that every point that is in that yellow stuff, every point in there is going to meet all four of those requirements. It's going to, any point in here, like that point there, will be greater than 0 for the y. The x will be greater than 0. The y will be less than 10, and the x comma y plugged into that will be less than 540. Okay, but every point there, 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 and there will also meet the same criteria. This one we know to be 0, 0. This one here is going to be 0, 10. Okay, this one over here, just want to double check. That one's 36, 0, and 6, 10. Okay, 36, 0, right there. And 6, comma 10. So those are the points then that we're going to see if we plug them into our objective function, which our objective function was 60R plus 100p. So I'm going to type in 60R plus 100p. Okay, you can do this in a different calculator or whatever, but it says add sliders for R and P, so that's what I'm going to do. And now what I can do, remember, X was R, P was Y. Okay, so I'm going to type in 0, 0. So if I have 0 people for physicals and 0 for revenue, you see that I make $0, right? Okay, that optimized my objective function, but it optimized it in terms of a minimum, right? And hopefully that makes sense. Okay, don't open the doors and that's the amount of money that you're gonna make. Okay, 0, 10. So R being 0 and doing 10 physicals makes $1,000. Okay, so 0, 10, $1,000. All right, let's go to 610. Obviously, 610 is going to make more money, right? Okay, because that number went from 0, that one stayed the same, so let's make 1360. So 610 makes 1360. And then the next one was 36 for R and 0 physicals. And I make 2160. So 36, 0 allows me to make 2160. So which combination should I do? I should do 36 routine physical or routine visits and 0 physicals, and that's going to allow me to make the most money. Okay, so basically I become a doctor that says I'm not doing physicals because it doesn't make sense for me to do it. Does that make sense? Okay, some businesses that you go to, let's say that I go, let's say we got a business like Pepsi in town, okay, and let's say we got a business like, so we got a Pepsi distributor here in town, right, out on Greeley Chapel Road. Let's say we've got another, like pop distributor. Let's say we've got, who makes 7-Up? Is 7-Up different than Pepsi? Does Pepsi make 7-Up? You guys know? Is that? Let's say we got Pepsi and we got Coke. Those are different companies, right? So let's say Pepsi says we're going to make cans and bottles. Okay, per what our data tells us, we can make money off that. Okay, well, you might assume then that Coke is going to make cans and bottles, right? But Coke, depending on the procedure and how their operations work, it might not make sense for them to make cans, and they might just make all bottles. Does that make sense? So that's this situation. Some doctors will do physicals and some will do routine physical or routine checkups. Other doctors might say, nope, we don't make money off physicals, we're not going to do it. Where you might assume just because I go to the doctor that they do all things that doctors will do, right? But you don't get the same services at equal types of businesses because sometimes they have constraints that limit the amount of money that they can make off of giving those services, so they don't. Is that okay with everybody? Does that make sense? So a lot of time, what I want you guys to understand, a lot of things that drive everyday services, everyday experiences have a mathematical background. They have that's their decision platform. Okay, and without it, they're just making decisions that might not make them the most money. They might not become the best business person. Okay, so someday when you're running Texas Roadhouse and you're the guy in charge, maybe you look into this kind of stuff. Okay, now they have programs that do this. So that scenario when I say, how many people we might have, a group of 2 people, a group of 3 people, a group of 4 people coming in. We know how long they're going to stay. We know how much money we're going to make off them, that kind of thing. There are programs that you can fill in all those constraints, and it'll automatically tell you how to schedule people and that kind of stuff. Okay, but the hope is that the person that wrote that program had a math teacher in high school that taught them that stuff. Okay.